Alright, so the monkeys are back. So in the 21st day, we meet with the monkeys again, but the elephants let us know that they only want to play like a game, and if we manage to get the correct answer for the riddle, they will help us. So basically, the core idea of the problem is that we have a graph of math operations, and these operations can be addition, subtractions, multiplication, or divisions, and the leaves of the tree will be integer numbers. So what we have to do for the first question is to compute the entire sum that we get in the root node. But then, since the monkey to elephant to human translation is pretty bad, it seems that we were wrong, and the actual thing that we have to do is more complicated. So actually the root node will be an equal operation that checks if the right hand side and the left hand side are equal to each other. And the node labeled with human is what we need to input in the tree so that the two branches are equal. So that's also what we need to provide as the answer for the question. What should the human node be changed to so that the left hand side and right hand side of the node are equal to each other? So yeah, basically to solve the problem, I created this operation enum, and as I said, we'll have a single number for the leaf node, and the other nodes will be basically references to other nodes. So it's fine to use two string values as parameters for each operation because they will only refer to other monkeys. For example, they won't have numbers in them. They will just shout the operation, and what two other nodes will have to be checked. So yeah, parsing the input wasn't that difficult. I just had to split the input by these characters for the plus operation with a plus, minus, multiplication or division, and also the first time I try to parse the string as a number to make it a leaf the node. Then to parse the entire input, I created this hash map that will map the name of the node to what operation it does. So it will basically build a graph. So we have to split the input into lines, and then we have to map each line using the operation parsing function. So we split by a semicolon, and the first part of this split will be the name of the current node, and the right hand side will be the operation that it has to do. So as I said, the first part was pretty easy. We just have to start in the root node and then do a depth first search. And so basically the base case is the leaf node. If we find the leaf node, we just return the number, and if we find any other type of operation, we just call recursively DFS on the left hand side and right hand side with the given input. Then for the second part, I created this helper method called reverse answer that receives as input the answer that was reversed so far, the node name of the current node, and the input, which is basically the graph, and it has to return an option I size. So the base case is if we are a human, like if the node is human, we just return the answer that was reversed so far, and otherwise we just want to check if the current operation is an operation, because if it's a number then it means that that's a monkey, so we don't care about that, so we can return a none. So basically after we have an operation, it means that the human can be either on the left hand side or on the right hand side. So we can apply the reverse answer function in two cases. The first case is to try to reverse the left hand side, and the other case is to try to reverse the right hand side. Let's say that we start with the first case and we apply depth first search on the right hand side and the input. So we try to get the answer that we would get on the right hand side branch. And let's imagine that the left hand side is a human, so we try to reverse the answer in that direction. So we take the answer that was built so far, and in the case of an addition we would have to subtract the right hand side answer. Then for subtraction we'd have to add the right hand side answer. Then for multiplication we have to use division, and for division we have to multiply the reverse answer with the right hand side answer, and we just go to the left hand side part of the tree, and basically this will return us either some value or a none. And the reason why I couldn't do it in a single line, like in a single step, is that if the human is on the right hand side, the reversing of the answer looks a bit different. So for addition, it's the same thing because it's addition. The same thing for multiplication, you still do the division in the same direction. But if you have a subtraction, the subtraction isn't really like it doesn't work to interchange the parameters of the subtraction as you would do for addition. So you have to multiply everything with -1, and the same thing is applicable for the division. You can't do multiplication to reverse this type of division. You would have to divide right hand side with the answer. So yeah, this was a bit tricky to wrap your hand around, but yeah, I mean it works, so it's fine. And at the end we have to return either one of the two options depending which one gave us the human node. So to be able to call this function, we have to do the same split on the root node, take the left hand side and right hand side, and then basically just call reverse answer on both sides, and yeah, just get the one that returns the sum option, and one of them should work. So yeah, this was the 21st day. It was pretty interesting. Coming up with a solution for reverse engineering the answer was fun, but also a bit challenging. So yeah, if you want to check the code and see how I did it, you can check my GitHub, and see you guys next time. Bye bye.